So we can do one problem to calculate the super elevation of a main track. Okay. Problem: if a 8-degree curve track diverges from a main curve of 5 degree in an opposite direction in the layout of a broad gauge yard, calculate the super elevation and the speed on the branch line if the maximum speed permitted on the main line is 45 km per hour. Okay, so here the curvature of branch line and main line is given. Okay, that is curve track diverges from main curve is 5 degree and the branch track is degree of curvature is 8 degree. Okay, and here the speed permitted on the main line is given. So we have to calculate the super elevation and speed of the branch line. So that is the question. So first, in the previous lecture, I have explained the procedures or the steps for calculating the Kant efficiency. So in the first step is to calculate the equilibrium super elevation based on our equation, that is E is equal to GV square by 127 R. From this equation, we can calculate the equilibrium Kant for the speed of 45 km per hour. So it is a speed on main track. Speed of main track is 45 km per hour. So we can calculate the equilibrium Kant on the main track. So that is GV square by 127 R. So here G is, since it is broad gauge, what is the gauge distance? G is equal to 1.676 meters for broad gauge and V is 4.45 km per hour. Next, what is R? R is not given. Okay, that is radius of the curvature is not given, but instead of that they have given the curvature. Yeah, so what is the curvature of the main track? Main track degree of curvature is 5 degree. So if degree of curve is given, what is the equation for calculating radius? So this is the relationship between degree of curve and radius, that is D is equal to 1720 divided by R for length of the chord is 30 meter. That is for when we are assuming the chord length as 30 meter, this is the equation for this is the relationship between degree of curvature and radius. This you have studied in your survey and also in the first lecture I have explained this. Okay. So D is equal to 1720 by R. So R is equal to 1720 by D. So 1720 by that degree of curve we will get the value of radius of curve, radius of the curve, that is R. So R is equal to 1720 by 5. So 5 is the degree of curvature of the main track. Okay, so we are calculating the Kant or super elevation of main track because speed of the main line is given 45. From that we have to calculate the super elevation and speed of the branch line. Okay, so first we are calculating for main line. So main line degree of curvature is 5, so radius is equal to 1720 by 5. So E is, so put these values in the equation. E is equal to GV square by 127 R. So or 1.27 R means the value is in centimeter. If it is 127, that will be in meters. So here since it is 1.27, this E will be in centimeters. Okay, G is in meters, all others are metric system. So we have obtained E, that is equilibrium Kant as 7.78 centimeter. That is the first step. Then next, second step. What is the second step? Second step, we have to find out the permissible Kant efficiency for that track. That is the Kant efficiency for broad gauge from the table. From the table, Kant efficiency for broad gauge is 7.6 centimeter. Okay, so that has to be calculated from the second step. So in the second step, you write for broad gauge the Kant efficiency for main line is equal, that is permitted Kant efficiency is equal to 7.6 centimeters. Okay. So third step, what is the third step? We have to calculate the difference between equilibrium Kant and this permissible Kant, that is this calculated equilibrium Kant and this permissible Kant. The difference between these two has to be calculated in the third step. So that is 7.78 minus 7.6, that is 0.18 centimeter. Okay, so this all are for main line. We are doing this for main line. So for branch track, this should be reversed because when it is coming for branch and from main to branch, from branch to main, this sign will be reversing because it is negative super elevation. Okay, so therefore in the fourth step, this negative superelevation is equal to the maximum superelevation permitted on the branch track. So the cant which is to be provided for the branch track is just the reverse of this for main track that we have calculated the difference. So this will be equal to minus 0.18 centimeter, that is negative cant. So from this fourth step we have to give the negative value for this difference in cant. So the value is 0.18 centimeter, that is a negative cant. Okay, and so what is the cant efficiency for broad gauge 7.6 centimeter, which is the permissible value? The speed of the track will be, so cant will be equal to this 7.6 plus this cant, this negative cant for the branch track. So 7.6 plus minus 0.18, so this to be reduced, that is 7.6 minus 0.18 centimeter, that is 7.42 centimeter is the cant which is for the branch track. We are calculating for branch track, that is 7.42 centimeter. So this is E for the branch track. So we have to calculate the superelevation. Superelevation is 7.42 and the speed on the branch line. We have to calculate the speed. So speed we can calculate from this equation, that is E is equal to GV square by 127 R. From that E is 7.42, we have calculated as 7.42. So we will get the value of V. Okay. So V is equal to 34.7 kilometer per hour. So the theoretical speed on the branch line, this is the theoretical speed of the branch line, because the maximum speed on the branch line should not be more than 24 kilometer per hour as per the railway rule. So this is the theoretical speed, 34 kilometer per hour, that we have calculated. Okay. So so first you should by heart the steps which I have given here. So this is the this is the step which is given. So by step by step procedure you do the problem. First you calculate the equilibrium superelevation for the given track, then permissible has to be found out from the table, then calculate the difference between these two, permissible and the equilibrium, that is the obtained value, that is the superelevation value, and this is the negative superelevation for the next branch. For it may be for branch main track or maybe branch track. Okay, so we have to give the negative value. So this is the negative superelevation, and for the calculating branch line or main line, we are just reversing this, and it should be added by the permissible value. Okay, and that is the superelevation for that track. From that superelevation we have to find out the restricted speed. Okay, can do one more problem. A 5-degree curve diverges from 3-degree main curve in reverse direction on a layout of broad gauge. Okay, that is here main curve, degree of curvature of main track is 3 degree and that of branch is 5 degree, and the speed on the branch line is restricted to 35 km per hour. Here speed on the branch line is given, so we can calculate the superelevation, equilibrium superelevation on branch line. Okay, so equilibrium superelevation for the branch line is E is equal to GV square by 127 R, that is 4.71 centimeter. That is the first step. Then in the next step we have to calculate what is the permissible cant. So permissible cant is 7.6 centimeter. So negative cant is equal to equilibrium cant minus that permissible cant efficiency, that is 4.71 minus 7.6, that is minus 2.89. Okay, so this is the negative cant, because cant efficiency for broad gauge permitted is equal to 7.6 centimeter, this one. So we are reduce this permissible from the equilibrium cant, so this is minus 2.89. Okay, so this negative cant is equal to maximum permissible superelevation on the main line. So here we have calculated for branch line. So in the case of main line, the sign should be reversed because it is negative cant. So it will be equal to 2.89. Okay. Then theoretical superelevation on the main line will be equal to this permissible 7.6, since it is broad gauge, plus this one, because here it is plus sign, because we have reversed from here. So we have to add 7.6 plus 2.89, so 10.49 is the answer here. In the previous one, here we have reduced, that is 7.6 minus 0.18, because here it is negative 1. From this we have reversed this sign. Okay, so you remember these two problems are different. Okay, so here we have reduced because here it is negative sign, but here in this problem the sign is positive, so we have added 7.6 plus 2.89, so the value of theoretical superelevation 10.49. so from this one we can calculate what is the value of V. Okay, so V is equal to V is equal to 67 kilometer per hour, so it can be approximately 65 kilometer per hour. Okay, so this is the procedure how we are calculating restricted speed on main track or branch track. Here we have calculated restricted speed on main track. In the previous one we have calculated the restricted speed on branch track. Okay, so you should do more problems from your textbook. If you have any doubt, you can WhatsApp me, okay, or call me. Thank you.